In this video, we're going to talk about how to draw constitutional isomers. So let's start with this example. How many constitutional isomers can we draw given the molecule C4H10? So this is butane. And here's one way we can draw it. We can put all 4 carbons in a straight chain, or we can draw 3 carbons and put a methyl group on carbon 2. Now, the reason why these are constitutional isomers is because they have the same chemical formula, but they're connected differently. Now I'm going to draw it out. So for the first example on the left, you can write it this way: CH3, CH2, CH2, CH3. As you can see, it has 4 carbons and 10 hydrogens. Now for this example, we have a CH in the middle, surrounded by 3 methyl groups. And so we get the same chemical formula, C4H10. Now let's move on to pentane. Let's draw the constitutional isomers of C5H12. So we have 5 carbons. One way we can draw is like this. Another way is we can go down to 4 carbons and put a methyl group on carbon 2. Or we can go down to 3 carbons and put 2 methyl groups on carbon 2. And so these are the 3 constitutional isomers of pentane. Now what about for hexane? How many constitutional isomers can we draw for this molecule, C6H14? So the first one, let's start with a straight chain alkane. That's 1. Now let's go down to 5 carbons and let's add a methyl group on carbon 2. We could also put a methyl group on carbon 3. Now, we can't put a methyl group on carbon 4 because these two are identical. They're not constitutional isomers. In fact, if you try to name it, they would have the same name. So this would be called 2-methyl pentane. And then for the other molecule, you have to count in the other direction, going from right to left. So as you can see, it has the same name, 2-methyl pentane. Now, if we name the structure on the left, notice that this is called 3-methyl pentane. And so it's important to understand that constitutional isomers, they have the same molecular formula, but they're connected differently, and also have different names. The nomenclature cannot be the same. So let's see what other isomers we can draw. So let's go down to 4 carbons, and we need to put 2 methyl groups. So we can place both methyl groups on carbon 2, or we can spread it out. Put in 1 methyl group on carbon 2 and the other in carbon 3. So for hexane, I got 5 constitutional isomers. Now let's see how many we can draw for heptane, C7H16. Feel free to pause the video if you want to try it. So first we can start with 7 carbons in a straight chain. So that's a total of 7. Then we can go down to 6 carbons. We could put a methyl group on carbon 2, or we could put one on carbon 3. If we place one here, it will be the same as putting it on carbon 3. Or if we place it here, it's the same as putting it on carbon 2 from the left. Just keep that in mind. So now let's go down to 5 carbons. And so we need to add 2 methyl groups. We can add both methyl groups on carbon 2, or we could add 2 methyl groups on carbon 3, or we can place 1 methyl group on carbon 2 and 1 on 3, or we can place 1 on 2 and 1 on 4. So far we have 7 constitutional isomers. Now let's go down to 4 carbons. In this case, we need to add 3 other carbons. So we could place 2 methyl groups on carbon 2, 1 on 3. And I believe that's it for the 4 carbon chain. But you know what? If we go back to the 5 carbon chain, what we could do is we can place an ethyl group on carbon 3. And that's going to give us a completely different structure than anything we have seen. So for the 5 carbon chains, for this one, this is 2,2-dimethylpentane. This one is 3,3-dimethylpentane. This is 2,3-dimethylpentane. And this is 3-ethyl pentane. So that's completely different from the others. And so we have 9 constitutional isomers for heptane. Now let's move on to the next example, which is going to be octane. So for octane, there's a total of 18 constitutional isomers. So what I want you to do is pause the video and try to draw as many isomers as you can come up with. So let's start with an 8 carbon chain. So that's simply octane. Now let's go down to 7, and we could put a methyl on carbon 2, or we could put a methyl on carbon 3, or we could put a methyl on carbon 4. Now let's go down to a 6 carbon chain. So we can either place 2 methyl groups or an ethyl group based on the last problem. So let's start with 2 methyl groups on the same carbon. So we could place it on carbon 2 or carbon 3. Now we can place 2 methyl groups on different carbon atoms. So let's say carbon 2 and 3, 2 and 4, or 2 and 5. We can also place a methyl group on carbon 3 and on carbon 4, because that will be different as well. Now let's talk about adding the ethyl group. Where can we add the ethyl group and where should we not add it? We cannot add it on carbon 2 because the longest chain won't be 6 carbons. It's going to be 7 carbons. And so what we're going to have is 3-methyl heptane, which is the same as this one. So when adding the ethyl group, we have to add it to the 3rd carbon or more in order that the parent chain will not have more than 6 carbons. So we can add it on carbon 3 or on carbon 4, which becomes carbon 3 if you count it in the other direction. So there's only one location where we can add the ethyl group for a 6 carbon chain. Now let's go down to a 5 carbon chain. So we can add 3 methyl groups, or we can do an ethyl and a methyl. Let's start with 3 methyl groups. We can place 2 here and 1 here, or we could place 2 on carbon 2, 1 on carbon 4. We could place 2 on carbon 3 and 1 on carbon 2, or we can place 1 on carbon 2, 3, and 4. Now let's talk about the ethyl group that we can add. So we can add an ethyl group on carbon 3, and then we can add a methyl on carbon 2. Or we can add the ethyl group on carbon 3 and a methyl on carbon 3. So let's count how much we have so far. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So far we have 17 constitutional isomers. We need 1 more. So what do you think the last one could be? Well, we can't go down to 4 carbons. Maybe we could go down to 4 carbons. If we go down to 4 carbons, we have to add 4 more carbons to get 8 carbons. So we could put 2 on carbon 2, and we could also put 2 on carbon 3. So that's 18. So these are the 18 constitutional isomers of octane. Now what about this one, C2H6O? How many different constitutional isomers can we draw? So we can draw an ether. This is dimethyl ether. It has 2 carbons, 6 hydrogens, and an oxygen. Or we can represent it as an alcohol. Now what about this one, C4H8? We did C4H10, which was an alkane. It had the formula CnH2 2n plus 2. This one has the formula CnH2n. When you see that, it's either an alkene with 1 double bond or it's a ring. So for C4H10, we can draw this isomer, trans to butene, we can also draw cis-2-butene. These are cis-trans geometric isomers, but they're not constitutional isomers because they're connected the same way. But they are isomers though. We could also draw 1-butene. We can also draw butane, cyclobutane. Notice that each carbon has 2 hydrogens. We can draw a cyclopropane ring with a methyl group. And so those are some different ways in which we can draw a structure with this formula, C4H8. Now let's talk about cis and trans 2-butene. The reason why they're not constitutional isomers is because they're connected the same way. However, the groups are arranged in space differently. So there are stereoisomers, specifically cis-trans geometric isomers. So if we look at this carbon, it's attached to the same thing as this carbon. Both carbons are attached to a methyl group. They're both attached to a hydrogen and to another carbon. And if you analyze this carbon, it's attached to the same thing. The same carbon on the left. They're both attached to the same methyl group and also the same hydrogen. However, as you can see, the orientation of the hydrogen and the methyl group in space differs from this one. Here the methyl group is on the top, here it's at the bottom. And so because they're connected the same, they are not constitutional isomers. However, because the way the atoms are arranged in three-dimensional space, because it's different, thus we have stereoisomers. But in this particular case, specifically, cis-trans geometric isomers. There's many different types of stereoisomers, but cis-trans isomers are one subcategory of stereoisomers. And so we're going to stop it here for this video, and now you know how to draw different types of constitutional isomers. So that's all I got. Thanks for watching.